All right, so for Unit 7, we are going to take a look at what it means to be exponential a little bit more. Unit 6, we talked about different types of sequences, some being linear, some growing at different rates, and this is going to directly apply. Now, before we get into it, exponential growth and decay have huge application everywhere. You want your money, if you put it into a bank account, to exponentially grow, which is always a good thing. Talking about the pandemic that's currently going on, we don't want exponential growth because, as we're going to learn in these, they grow rapidly, very, very quickly. But to start, let's look at the difference between linear and exponential. So, question 3 says graph f of x equals 3x plus 1. So we should know that our y-intercept is at 1, and then we go up 3 over 1 to get the next point, up 3 again over 1 to get the next point. Okay, and then we can connect those with a line. So this is linear, okay? It goes up the same amount each time. As y increases by a certain amount, x increases or decreases by a certain amount. But let's take a look at graphing f of x equals 3 to the x power. Now, I would advise for this one to create a t-chart, okay? I don't know why I put the y that big. But yeah, make a t-chart. Okay, and then fill in some values. So let's say 0, 1, 2. Okay, so for t-charts, you always want a minimum of 3 values. Well, for this one, we'd have 3 to the 0 power, which anything to the 0 power is 1. Then we'd have 3 to the first power, which is 3. And then we'd have 3 to the second power, which is 9. So now we can graph these. So we're at 0, 1, just like the last one, but now we're at 1, 3, and then we're at 2, 9. So what do we notice here? Okay, if we take a look, we see that although our first value was a little smaller, by x equaling 2, we shot above the y value for 3x plus 1. So that should show you that exponential, although it may start off slower, it explodes. Okay, it gets bigger and bigger rapidly.